go ahead. It's going to say untitled graph. Actually, you might have to do like f of x equals, type something in right now. And then click up here and click save. And I want your name needs to be somewhere in the name of this graph, because you're going to send it to me. And if I have 15 of them and they all just say cup project, I'm going to lose track of whose is whose. So your name first or last or both or something, so I can tell it's you. We don't have a lot of duplicate names in here, so it'll be fine. So, call it Hyatt Cup Project. But don't put Hyatt, put whatever your name is. Something of that sort. And you want to save it. And then as you make changes, you want to periodically be hitting that save button. Because it does not save the changes for you. Let's do, I'm going to do a super duper simple. You cannot do it this simply. I'm going to do something like 3x plus 2. Oh, no, let's not do that. Let's do like 1/3 x plus 2. And let's make it plus. All right, if I do it in millimeters, I think our lives are going to be easier if we do it in millimeters. You got to keep in mind, if you need to, we're not very metric system minded over here. So like 2 millimeters is, like this much. It's nothing. So if I were to rotate this, I would only have a 4 millimeter base right here. I also would suggest rotate around the x-axis, because it really doesn't matter which axis you rotate it around, whether it's x or y, but it's just so much easier to do all the calculations if it's around the x-axis, because once you create it, if it's around the x-axis, it's going to be like on its side whenever you rotate it, but you can turn it whichever way you want to print it. So do the x-axis, it'll be easier, unless you're just really wanting to challenge yourself with the y-axis, but it will not make your product any better by doing the x-axis. So like right now, I'd only have 4 millimeters, which is, less than half a centimeter for my base. So if I try to like make this a cup, it's going to flip over. It's not going to sit on that base. So maybe I should do something like 15 there, because that would give me 15, you got 10 millimeters in a centimeter. So 15 is going to be like 3 centimeters across for the base. So now we're looking like that far. That's more reasonable. It can sit on that. So there are several ways that you can set this up. But in general, what's going to happen here, I also would suggest using 0 as like your starting point, right? It could be the top of your cup or the bottom of your cup. It does not matter. But I would suggest using 0 as your starting point. So if I want to find the volume of this line rotated around the axis, I would do pi, and Desmos will do integrals. You just got to go down here, functions, and right here's your integral symbol. And I'm going to go from 0, and I'm going to put a right here. And I'm going to tell it f of x squared dx. And add slider for your a. So what this is doing is pi radius squared, right? The f of x, that's going to be your radius because it's going to be from f of x down to 0 here. You don't want to do this with like an inside-outside radius sort of thing, because like the volume is what's going to be rotated there. So you really just want to do like a disk method, no hole in the middle sort of thing, because what we'll do is this is going to be like our outside surface, and then in the program we can thicken it so it will have some width, and it will print for us there. So this is like super duper simple right here. So I will do this. I might want to do even something like x equals a right here, and x equals 0 to put some lines there showing me what part I'm looking at. And so right now I got this teeny tiny piece and it's rotated, and I've got 722 cubic millimeters. I'm gonna write this up on the board too. So we're shooting for 29,573.5 cubic millimeters. It seems like a lot, but it's in, millimeters are tiny, so that's just a fluid ounce. So right now, this would not give me anything close, but I could change A to make it larger. Notice I've gone all the way out to 10 already, and it's not there. So if you click on that little button over here, you could make this go up to 100 or 200 or whatever you need. Keep in mind 100 millimeters is going to be 10 centimeters, which is probably too big. That's going to hold more than an ounce. So we can just drag this over till we're getting close. Looking for, there's 27. All right, we need to go down a little bit from that. All right, so I could just keep playing with this. That's going to be 23.9. Okay, that is, I think, 573. So maybe 9, 8. That's too much. 9, 7. Okay, 9, 7, 5. Let's see, 5, 7, 3. Too much. 4, 1, 2. All right, 1 works. Then you could put a 5 behind that. 5, 7, 3. 5, 3, 7. That's going to be probably close enough. If you, Oh gosh, 29. Sorry. Let's go back. 4, 5. All right, 5. Okay. All right, 25 point. Let's see. Oh, way too much. 1, 4. Okay, that'll work. What else? 2 does. 2's too much. 1, 5. Okay, that'll 6. No, 6 too much. 5. 7. Oh, that's close. Let's put a 2. There's a 5, 7, 3. I go here. This is going to be, if you're getting it to round to this, that's probably going to be close enough to get you there. So this would have a volume of 1 ounce. So this is one option, right, that I could go with something like this where I'm just picking a shape and then I'm adjusting that A. But be careful because, see, where did my models go for that? I'm pretty sure that's the route this person right here took. And it ended up just being like a squatty looking dog bowl sort of thing that worked, but it did not win coolest cup, as you can imagine, right here. This one took me a lot more thinking to get it to line up. First I had to get those two, I made a piecewise function, had to get a match up, and then had to work on it a lot more for that. So that's an option of a way to approach it. Let's go back and look at some other things that you can do. Let's say that we decide that we want our cup to be 4 centimeters tall. So rather than going from 0 to A, I could go 0 to 40 right here. And so X equals 40. I want it to definitely be that tall, but if I go to 40, it's way too big, right? It's going to hold over 2 ounces if I do that. So what could I do here to make it, to make the volume? Let's try just plus 10. Okay, that gets me down closer. Maybe make that slope maybe 1/5. Okay, now I'm below. So now I could like play with it, right? Or I could even do, like, instead of doing my slope as a fraction, maybe do like 0.2, point, 0.25, too much, 2, 3. I could play with it. You know, you guys get the idea of doing that. You could play with that. Now, I want you to do an equation that's like a little bit more difficult than that. But you can do that. Let me remind you a few things about functions in general. So if I've got, because this will be helpful for you to get the look that you want for your cup. If it'll come up. Oh. Okay, so just remember, whenever we're talking about equations, if I've got a f of b x plus c plus d, we did this a lot with trig functions, but it works with any function, right? What does that a do to the graph? Which way? No, vertical, stretch, or shrink. Right, goes in the direction of things you should. If you want to make it taller, you're going to put a big number there. If you want it shorter, fatter, you put a small number there. What does the B do? That's horizontal. Stretch or shrink or dilation. What's the C do to it? Left or right? And what's the D? Up or down. So you can do this with any type of function. So like if you want a sine curve, you can start with a sine curve. If you want like an exponential, like an e to the x sort of function, then you can start with this. You're probably going to have like a pretty, like a small number right there, or it will get big way too fast and you'll have something crazy looking. But you can do this with any function there is. If you want to do a piecewise in Desmos, let me show you how to do a piecewise. Okay, here's how you type in a piecewise function in Desmos. You'll say f of x equals, you will do a squiggle there. You type your condition in first, so you might do like 0 is less than or equal to x less than 10. And then you do a colon. Let me make this bigger too so you can see. You'll do a colon, and then you'll type the equation. So maybe like 0.5x plus 10 right there. And then you do a comma for the next part. Although the only thing I don't like is that does go away whenever you do that. And so like I'm just going to do one I can, like let's even do this. Let's say that I want what would be good to connect to that? A sine curve. Let's say I want a sine curve to connect to that, right? So I could do sine, oh no, I got to do the conditions first. So 10 less than or equal to x less than, I'm going to put a b right here and add a slider and sine of x. Okay, this will work, but the problem is my b is too low. I need to make it higher because right now it's not falling in that category. There we go. There it is. And then like obviously sine is not matching up with this, so you could go You can either mess with it from here, like you could, it's definitely going to need to be moved up. So if we move it up 15, you're getting close. And then you can even do a little, like if you want to get that to match up perfect, I'll show you what I would do here. Let me get this how I want it. Okay. Like if I want that to match up perfect, I know like that I'm going to stop this at 10, right? So if I do 0.5 times 10 plus 10, I'm going to get 15. So the coordinate there at the end of my line is 10, 15, right? So I need sine to be continuous with that. So if I have sine x plus, I'm going to put a d right there, y equals sine x plus d. When I plug in 10, 15, when I plug in 10, I need to get 15 out, so it's the same point. So I could plug in 15 for my y, 10 for the x. So I would have 15 minus sine of 10 would equal what that d should be, and 15 minus sine 10 is 15.544. Zero 2 right there. So if I change this to 15.54402111009, I just keep the whole decimals. That will work well. Now you can see it would be continuous. Oh, this would be so cute, especially if it had. Oh, this is gonna. It's almost gonna look like a ice cream cone or something. So if we now, if I'm looking at my pi integral, I'm gonna let you guys mess with this in a minute. From 0 to b of f of x squared dx. Like right now, it's too small, so it would, you'd have to extend this out. This might be a little tall, and it's probably not the best base right here. Like I wouldn't go with this design, but you go with a variation, or you might could like make that flare out. But anyway, you guys get the idea of the different things that you can do with it to get that designed. So I'm gonna let you guys play with it. I don't think we're going to be able to, like, get to putting it into the Fusion software today. You're probably going to still be messing with this today. But I do need everybody to have access to the Fusion stuff, because I know some of you said that you did not get an email from, you should have gotten an email last week from Autodesk. So go to your school email and search for an email from Autodesk. You may even need to check like your spam folder. I don't know, depending on how you have your settings. I know Troy said you got it, right? And you created your account. So I need everybody to go check their email and see if they have got that, and you can start your account through that email. If you don't have that email, I need to try to send it to you again.